Okay, I guess you already know where to find Slido. So welcome to my talk, Reflection-Free Application with Micronaut. My name is Vlad. I work in a company called AgroPools. We make software for managing social media profiles. So just a bit about me. My main language is Groovy, and I've spent this kind of cycle. I've started with Gaelic. If you can't remember, or if you heard about it, it's a toolkit for Google App Engine. Then I moved to Grails, and now as a Grails, they won't say it, but they slowly evolved to Micronaut. I'm using Micronaut now. So I've started using cloud, even at the time it wasn't that fancy. I like testing, I like DSLs, and if I find a gap, I try to fill it with some tool. So I've just created a spreadsheet builder, for example, some testing frameworks. And I also created a couple of libraries to work with Micronaut, especially the AWS. So what we're going to talk about today? We just try to summarize the problems with current Java and then move to Micronaut on what are the solutions for the problems. So, what are the problems of current Java or Java frameworks? As I've called this talk a reflection-free application with Micronaut, it's probably good to say why reflection is bad. You know, as long as I develop software, just people are saying, okay, don't use reflection, usually because it's slow. And actually, I just learned a new thing about it's also cost you a lot of memory. So every time you the first time you use some reflection on a class, it's just going to cache all the reflection data until just you run out of the memory. As I said, it's slower. And what starts to be a big problem or a big challenge recently, this thing called GraalVM, it doesn't play well with the ahead of time compilation. So, the compiler or the pre-compiler, how it's called, just don't know what classes are going to be used if you use reflection. So it's good if you can try to avoid it. So what could be the other problems? These are the problems which actually Micronaut is trying to solve somehow. It's the limited annotation API. For example, I think there's so many even like Java standards which are using the meta annotation, for example. You can use meta annotation, but it's not in a Java. They always have to find a solution how to deal with meta annotations. And type erasure. That's the complete problem. You have a list of tasks in your source code, but when you try to ask what type of list is it in the runtime, you don't know. Even with reflection, there are certain tricks that people using, but it's difficult. Well, class path scanning, it's a different thing. Okay, so I have this 50 jars on a class path, and I want to scan each of them if they contain something, some class. Not a good idea, probably. And then I'm a class loading, whatever. So as I said, I started with cloud, I'd say 10 years ago already, with Google App Engine. So why is Java and cloud so different? Because if you have your application sitting on a server, running forever, it's okay if it just starts in 1 minute. Okay. And usually you don't care if it just eats, like 2, 4, 8, 16 gigs of memory. But if you're in a cloud, you basically build by something called gigabyte seconds, especially in the environment I'm using AWS Lambda, so we just built for gigabyte seconds. So if you can, just try to run faster, if you try to run with a smaller memory footprint, it could actually save your company a lot of money. And in cloud environment or in microservice environment, you don't want to have like long cold starts, because for example the cloud function, they usually spin up randomly, once a minute, tenths a minute, and you want to have the startup time as fast as possible. So let's move to Micronaut. Who have heard about Micronaut before. Was it last year here? No. So it's basically a full stack framework. You can do anything with Micronaut. And they claim themselves to be natively cloud native. I think we've heard about being cloud native a couple of times during these 2 days, which means they just focus to conform with the constraints of cloud I've mentioned before, which is fast startup time, and also it means like support the tools used in production, like Netflix suite, like AWS, like tracing tools, like service discovery tools, like console. So just sum up what you can build with Micronaut. Typically, you can build, like like web server application. It's pretty nice to work also like web server clients or HTTP clients. You can actually build a CLI app. So if you are fancy to build a CLI app with a good DI support, you can use Micronaut. And of course, you can build some functions, could be cloud functions. I don't know, out of box, you just go with AWS Lambda. I think it's a major one. But you can use also OpenFaaS, cron jobs, and you can, listen to your Kafka streams or whatever. So this is the current state of the art. It's probably not complete, but this is what they just, sum up on their website. So they support, one of the major technologies you're probably already using. If your technology is not here, it probably means that they're working on it, or it's kind of niche. And okay, well, I wouldn't call it demo because I call demo, like a live coding. But let's say showtime. I'm a bit afraid of doing the live demos during the lightning talks. So so what do I have here is a simple controller, simple Micronaut controller. Oh, okay, it's a Micronaut controller. Because it looks a bit familiar, does it, if you're familiar with Spring? Okay, so actually you can just grab your Spring controllers and just say, okay, I run it as Micronaut. If you don't trust me, it just uses all the Spring annotations. And actually this also is a nice explanation about the limits of annotation API. There's so many ways how to, for example, describe something is going to have a get mapping. So okay, I have a get mapping, or I can just say this is Spring 1, or I can use just get, which is the original one. And so this talk is about reflection free, is it? So how do you find out which annotation are being used here? Actually, I'll just take a look if it's running. You may not believe me, it works. Just take, like random Spring annotations over there. I should probably say just, it's regular task endpoint. I'm not really fancy in front end these days. Okay, it somehow starts. It took pretty long. It's just 2 seconds. I wouldn't brag about this one. Okay, let's try to execute something. Just list all tasks. Okay, it works. So it works even with the Spring annotations. So is it reflection free or not? So if you want to know it, you have to actually go to inspect the build classes. So here sits my task controller somewhere. Okay, it's the same as I've built. But Micronaut is doing this kind of ahead of time compilation during the compile time. So during the compile time, it just computes all the annotation it's going to ask during the runtime. It creates the classes for creating new beans. So if I go to, there are 2 of them, this one. So you can see it. So whenever Micronaut wants to create new controller, it just calls this method instead of just using reflection. And if it asks, for example, for the first annotation metadata of the first method, which is probably the first get method, so you can see it's actually the aliases for annotation works pretty well. So okay, so this is not the Spring one. This is the Spring one. Okay, it's a Spring one, but it also can be read like the Micronaut one in other alias and whatever. So it just builds all the informations are built during the compile time. So just get back to the very simple controller. There's a lot of things to show. Okay, so DI. So at the end, the Micronaut is just a DI framework. Maybe with the just to emphasize the IOP capabilities. Okay, so well, no, it just you don't have to do anything special because again, controller is a bean. So okay, it's a bean. And if it's a bean and it has a constructor and only one constructor, we're just going to inject it with something called task repository. And you can see there is no HTTP responses. It just returns some objects, tasks. So how does it convert it to JSON back and forth? It uses JSON. I think JSON is kind of standard as well, so it uses JSON. And actually, because the task is entity, I will talk about it later, and entity is, oh, it's not in here, because it's not the, but entity also somehow maps to something called introspected. It also built all the information about the task class, task objects in the compile time. And for parsing and for printing JSON files, it will also use no reflection, which speeds up things a lot. And this is normal thing, I just use the Spring one, but you can use, of course, you usually will use the Micronaut ones if you write Micronaut application, but it was just for demo purposes. What is nice, for example, it handles optionals in the very sensible manner. So for example, if I say, where's my HTTP file, there's no special handling for this optional empty here. It doesn't change the status. But okay, I just say give me task 666. Oh, it's not there. So it automatically maps, for example, optionals to page not found. So, and other things. And it's just a coincidence. So what if I, for example, want to create a task, which is a bit fuzzy, just someone should fix the build. You can remember that nice slide you've seen like 20 minutes ago. Okay, let's try it. Oh man, nah, don't use someone. So how does it work? You can see the appropriate response. So the recent thing which was added in version 1.2 is also a reflection-free bean validation. So any bean you annotate with that at introspected, or if it's just like a singleton or any bean, it can be validated. For example, this controller. So you can see it's non-empty. So you can use just regular JAVAX validation constraints. You don't have to, invent your own. And you can build your own, like say, okay, no fluffy summary, just be specific. That's it. Oh, or it's not enough, is it? So No. That's it. So just implement or create, actually just handled by Lambda, just create the constant validator and say, okay, if it's, let's say there's some. And as I said, this is also all reflection free, because the Hibernate validator, which was the previous implementation, was so heavy in terms of memory, in terms of reflection or whatever. And you can check it here just if it works or not. I'm not going to launch it now. Okay, so I have a checklist actually, just not to forget anything. Okay, compiler generation, validation, here we go, testing. Testing is very simple. There's a Micronaut test annotation, which basically spin ups the application context for you. You can just inject whatever you want, any bean which is present in the context. You can mock stuff, which is a bit overkill in here. And this is basically an integration test, because Micronaut, as they try to start as fast as possible, it's just cheaper to spin up the whole instance and run the tests, or the whole application context. Okay, so maybe the least interesting. Okay, so what is this repository thing? Okay, so it's just an interface. So you're probably familiar with this if you know like Spring Data. So it's just interface. It actually extends this CRUD repository with very, very expected methods, save, delete. And what is it? This is the JDBC repository, so don't expect anything fancy. You just work with, like plain old SQL calls. It works with the most common databases, H2 for testing, MySQL, Postgres. And what you can do, well, of course, you can write your custom update methods. So, update whatever you want. You have this kind of dynamic finders. So, just say find by all by done. And it basically translates this into something like this. It will just add this query annotation in the compile time. Update done, you can just update one thing. You don't have to update the whole bunch of stuff. I truly believe it supports transactions as well. What it doesn't support is something like save for update, because you have to manage this yourself. I think I have to done it as well here. If you have the update task, okay. If it doesn't exist, or then update it. Okay, I'm not putting it in one. And as you probably noticed over there, you can just say, okay, you can just put your native query. If you are good in writing SQL, you can just put there your own query, and it works. You can test it. So, HTTP file. This is the search endpoint somewhere. Okay, have I mentioned Spring somewhere? Okay, some task about Spring. Probably some task about Micronaut. Okay, there's a lot of tasks about Micronaut. So, what is it good for? I believe I've shown all the cases I wanted. Native queries, custom methods. That's okay. Just do Josh Long session now. Okay, so Micronaut is reactive by nature. So what you can actually do is, let's start with my custom method. Let's say this is flowable. So this is flowable. This is also flowable. And if I restart it, You should be still able to search stuff. Search for Micronaut. Okay, it still works. So you can use basically whichever reactive implementation you want. I think you can use like RxJava objects. If I've shown you, you can use the reactive streams as well. Maybe even like reactor, like Flux and whatever. And now the last thing. I've done a bit of trick when I created this project, because this is actually the AWS Lambda project, and it works with API proxy gateway. If you're familiar with this, it's something you can just create in Amazon and say, okay, this HTTP request is handled by this function. So I have my function running it in the cloud, and actually I can ask cloud as well. Okay, and that's not all of it. Actually, the function is compiled with GraalVM. So if you Micronaut, I would say, is kind of Graal first framework. So you just get a bunch of tools for free when you create it, like a Docker file to compile to native image. You get the file to run locally. This is the AWS thing. And what is it good for? So I would just make some demo. I would just try some load testing, and this not very complicated endpoint, just backing one database. You can actually run it with 128 max of memory, and you will even not use all of it, and you have a pretty good response in 30 milliseconds. This is probably cold start, so it's 300, but otherwise. Okay, it's a summary, just what I've said before. The main point is probably that reflection breaks these cool new AOT frameworks or tools, and Micronaut and Graal really works pretty well together. I wish I could, compile it here, but if you've been here before, it takes really a lot of time, especially on my machine. Okay, thank you. And I think now there's time for Q&A, if there are some questions. Okay, it was already there, was it? So, no, I haven't. Since I haven't, because this is pretty new stuff, and we still use the reflection-based approach because most of our Lambda functions are written in Groovy, so there still are some reflections. But even for that, it's good. How do you actually? Haha. Okay. This is something I've missed. Thanks for the questions. So how do you use the goodies from Micronaut? You have this thing called bean introspector, and you ask it for the precompiled something called bean introspection, and say, okay, give me all properties annotated by ID, or there's like tons of other methods inside. And then you can, for example, create new task using that precompiled class or helper class. You can set properties, again, reflection free. And this is wrong for some reason, I don't know. Okay. So how do I get it? You can, if you want, you can use, so does Micronaut implement all the code that actually uses reflection, or is there best of both worlds way? Well, they definitely start with the existing libraries, and if they see there's a problem, they try to rewrite it. For example, like I think this is not just about reflection-free, but for example, I know the console client were pretty heavy, so they just used their own console client, write their own simple wrapper about the console API. So they're moving forward, I believe. So for example, they created this bean validator, which is reflection-free instead of Hibernate validator. They maybe still have some different frameworks or part of the ecosystem they want to rewrite reflection-free. But you can use whatever you want. It just depends. If you just want to run it normally as a Java application, you have no limits. If you want, for example, to precompile it with GraalVM native image, you have to be more cautious. Okay, so any more questions here from the room? No? Okay, so thank you.